Hello, welcome back. Today I want us to talk about supervisors. But before we look into the supervisors, I want to let's have a recap of what we learned in our previous video. So in the previous video, we had looked at process link, and in Elixir, processes can be linked together. So a good example of how you can link your process to another process is by using the task module function. For example, you can use the task async and the task async stream functions. Let's look at an example. So in this example, I want us to use the task async function, and we are going to make our task async perform a simple task of inspecting the process the process information of the process that is going to start. So let's look on how we can link processes together. So here we are going to link the interactive shell with the task process. So one way you can just use the task async. And let's inspect the process information. So process info, it takes in the PID. So I'm going to call self in here. So the PID that will be returned by calling self will be the PID of the task started by or rather the process started by the task async. So you could see that we have the task struct returned, and also we have the inspect of the process information. So the owner here is the PID of the interactive shell, and we can also call it the parent process. And the PID here is refers to the PID of the task started by the task of the process started by the task async. So the process information returned, I'm going direct to the links because that is what I am much interested with. So if you see the link inside here, we have the PID, which matches the PID of the owner. So that means our task process is linked to the parent process. So apart from the process link, I also mentioned another important term, which was the trap exit. So whenever you configure a process to a trap exit, you're telling this process to acknowledge the exit message of a linked process, but continue running instead of terminating. So this trap exit is very important when you want to isolate a crash. So in the example here, which I've demonstrated the task async, the parent process or the interactive shell process is linked to the process started by the task async. But this process, the task async process, is not configured to any trap exit. So what happens when an error occurs and we haven't configured a process to a trap exit? So let's intentionally add an error to the task process that we want to start. So this time I'm not going to inspect, but I'm going to raise an error. So I can just say raising an error. So you could see that we have an error returned back. And in this error, we have two runtime error. So the first runtime error is informing us that the task of PID 0.202.0 started from the PID 0.195 terminating. So the task PID mentioned here, it is the task process that was started by the task async. And the PID 0.195, it's matching the owner PID. So that means that is the PID of the parent process. So our task process has terminated. The second runtime error is informing us that the PID 0.195.0 has exited. So that means our parent process or the interactive shell has also been terminated. To prove that, you can run self, and if you run self, you can see that we are having a different PID from what we had initially. So this is what usually happens when two or more processes are linked together and they're not configured to a trap exit. So that means you cannot isolate a crash in that scenario. So remember that process link can shut down part of your system or the whole application. But sometimes this chain reaction triggered by the process link could not make sense in a case where let's say we have a web application, and this web application has different processes. So let's say the first process is the repo process, and the second process is the process for sending messages. In a case where the repo process crashes, it will make sense if the whole application goes down. This is because the repo process is usually the repo process is responsible for communicating with the database, and without that communication to the database, you cannot store or retrieve data. Then we have the process for sending messages. If this process crashes, it doesn't make sense if also the repo process is affected and the whole application goes down. So these are the cases where we like, or it will be necessary to isolate that crash. So one of the good example of a process on Elixir that is configured to a trap exit is the supervisor, and that is where we are heading to. So keep an eye on the next video where I'm going to go into depth on how supervisors work and how we can add supervisor to our task process and isolate a crash.